So hello my dear students, how are you? I hope you all are fine. Students, this is my first video. So first of all, I want to introduce myself. My name is Vivek Bhardwaj, B.tech M.tech in Mechanical Engineering, and currently I am working in Merit Institute of Engineering Technology as an assistant professor in Mechanical Engineering department. So students, I am starting this series of lecture to make you understand a very important subject. So my dear students, as you would have understood that what is going to be the topic of this video. So all my B.tech first year students, listen very carefully. The class is going to start on 4th of October, and when you will enter in your class, you will find so many subjects, you will get so many subjects which you are going to study in this first year, first semester. So among all these subjects, there is one subject which is belong to mechanical engineering branch, and the name of subject is Fundamental of Mechanical Engineering and Mechatronics. This subject is common to all branches, so every first year B.tech student has to read this subject in either his first semester or in second semester. So this subject is completely belong to mechanical engineering branches, and the unit which is coming in this syllabus is completely belong to mechanical engineering branches. So but no need to worry about it. Most of the CS branch and electronic branch and IIT branch students are thinking that why we are going to study this subject and it is going to be very tough. So don't worry, I am with you. I will teach you everything. I will make you understand each and every concept. So no need to worry about it. I can assure you that if you will listen my lectures carefully, you will obtain 100 out of 100. So let us start the video. So first of all, I want to tell you that this subject has total 5 units. So I'm not going to tell you about all 5 units right now. Just in this video, we will focus only first unit. And the first unit belongs to, as you can see, the first unit, Introduction to Mechanics of Solid. So topics are given: normal, stress and strain. The topic is normal and shear stress and strain, Hooke's law, Poisson's ratio, elasticity constant and their relationship, stress strain diagram for ductile and brittle material, factor of safety, basic numerical problems, types of beam under various loads, statically determinate beams, shear force and bending moment in beams, shear force and bending moment diagrams, relationship between load, shear and bending moment, and some basic numeric problems. So it is mentioned along with this unit that this unit should be covered in 8 lectures. Let's see, and I hope I will cover this complete unit in 8 lectures. So let us start the first topic, normal stress and strain. So first of all, we need to understand that what is stress. So first of all, by this flow chart diagram, we can easily see that we can see the classification of stress. So first of all, the stress is broadly classified in 2 types, that is normal stress and shear stress. Normal stress is again classified 2 types, that is longitudinal stress and volumetric stress. Longitudinal stress is again classified in 2 types, tensile stress and compressive stress. So we will discuss all these types of stresses one by one. To understand stress, we have to understand some things, like let us assume a circular bar. This circular bar is subjected to some kind of tensile load which has a tendency to elongate this circular bar. Due to this elongation, the placement of the molecules get disturbed. So as we all know that the solid metals are molecules are very closely compact, closely packed, and the intermolecular forces between the molecules of a solid metal is very high. Whenever this force has a tendency to elongate the bar, so the molecules create an internal resistance which create a resistance against this external force and try to restore this deformation. So we can see in picture if I cut this bar, we can see some kind of internal resistance force is acting opposite direction of the external load which is acting on one end of the circular bar. If we cut the other side, so we can easily see that some forces, some internal resistance forces are acting this side against this external force on this end. If the external load is subjected on a bar is applied under the elastic limit, so there is deformation takes place and the internal force generated by the molecules is equal to the external force applied on the two ends. So it cannot be measured. So by the help of this diagram we can easily find that what is stress. So stress is total internal force per unit area known as stress, and if it is represented by sigma, so we can find out its formula, or we can calculate the sigma by this formula. Sigma is equal to F upon A, and the unit of stress is, as we all know that unit of force is Newton and area unit is meter over here. So the unit of the stress will be Newton per meter square. We need to understand one more thing, that whenever a circular bar is subjected to some kind of pull force which has a tendency to pull the shaft, due to this pull loads it elongates in the direction of force. So whenever a bar is subjected to tensile force, the corresponding stress generated due to this tensile force is known as tensile stresses. On the other hand, whenever some kind of loads has a tendency to shorten the bar, or the nature of the force is pushing the bar, so these loads are known as compressive loads, and the corresponding stress generated due to compressive loads is known as compressive stress. So I hope you are understanding what I am telling you. One more thing, dogs are barking outside. So this video is recording in my room, and the time is night 10 p.m. and it is very difficult to, I have to switch off the fan, because otherwise the fan voice will record in mic. Okay, now come to the topic. Now the second topic is shear strain. So I told you that whenever a circular bar is subjected to some kind of tensile load, its length will increase. So we assume that it elongates, not that much big amount that we can easily see, but it elongates for some amount. Suppose the initial length of this bar is L, and now after applying the load it elongates and its length increases, suppose del L. So the strain is change in length upon original length. So formula will be del L upon L. So strain has no unit. So I think after all this thing you must have understood properly what is compressive stress and what is tensile stress. Now come to the next type of stress, which is volumetric stress. So let us assume a cuboid and it is subjected to some kind of loads, and due to these loads or the after effects of this load, so due to the change in volume, the stress is also developed in this cuboid, and the corresponding stress is developed is known as volumetric stress. So now come to the next topic, that is shear stress. So what is shear stress? Whenever a tangential force applied on a body, so it has a tendency to twist the body in the direction of force, or we can say distort the body in the direction of force. So loads are subjected on a body in such kind of position, so the corresponding stress is developed is known as shear stress. So the formula will be same, as we know that the normal stress is equal to force upon area. Similarly over here also the shear stress is equal to force, that is tangentially acting on the surface, above surface, and the area of this surface. So you can see the formula. So as we have the classification of normal stress, different type of stresses we have studied. Similarly we have different type of strains also, like normal strain and shear strain. And normal stress is again three types: longitudinal strain, lateral strain, and volumetric strain. So come to the next slide. What is strain? As I told you, there are two types of strain, lateral and longitudinal. So let us discuss what is longitudinal and what is lateral. If the strain is generating in the direction of force, Suppose force is applying in this direction and the length is increasing in this direction. So this corresponding strain is known as longitudinal or linear strain. But on the other hand, when a bar is elongates, can you imagine what about its cross sectional area? I mean the diameter. Yes, it is decreasing. Whenever the bar is elongates in this direction, in the direction of force, the length of the bar will increase, but the diameter of the bar will decrease. So the strain is developing perpendicular direction of the force is known as lateral strain. If a cuboid has length, breadth and height and the force is applying in the direction of L, so del L upon L will be the longitudinal strain and del B upon B and del H upon H will be the lateral strain. So if a cuboid is subjected to a tensile force in the direction of, force, one longitudinal strain is developed but two lateral strain is developed. So keep this thing in mind, one longitudinal strain and two lateral strain. So similarly, when a volume or a cuboid subjected to a compressive load all along the direction, and we can assume that we have immersed that cube or cuboid in the water, so due to the pressure of the water, its volume will decrease. So this external pressure causes change in volume. So this change in volume per unit volume is called volumetric strain. Now come to the next topic, that is shear strain. So in this figure we can easily see whenever a tangential load acting on a block, so due to this shift or due to the distortion of the body, strain is developed in the body. So we can see a block ABCD. When a tangential force acting on this block, so the edge shifted at an angle phi. So phi is nothing, it represents the shear strain in radian. So we can easily calculate phi. So apply the formula, tan phi equals to perpendicular upon base. So perpendicular will be CC dash and base is height of the block. So we can assume that angle is making by this shift phi is very small, so we just neglect the tan and we can directly write it phi is equal to CC dash upon AB. So this is the formula for strain. Now come to the next topic, that is Hooke's law. So what is Hooke's law? First of all, I want to tell you some history about it. Hooke was an English scientist and his complete name was Robert Hooke, and he did some experiment in 1660. Then he conclude all his experiment and give this law. So he stated that whenever a body is subjected to any kind of particular load under the elastic limit, so the stress developed in the body is directly proportional to strain. So you can see stress is proportional to strain. So to remove this proportionality sign, we have to put a constant of proportionality. Over here we are writing capital E. So capital E is the constant of proportionality and it is also called Young's modulus or modulus of elasticity. It is a material property and Young's modulus is different for each and every material. So by this formula we can find out that E is equal to stress upon strain, and if we put all the values of stress like P upon A for stress and del upon L for strain, so we can easily find out change in length by this formula. So this is the Hooke's law. So you can see, so by the help of this formula we can calculate any unknown quantity like P, length, change in length, area, Young's modulus. So any quantity we can calculate easily, whatever the type of numerical is coming in exam, so we can easily calculate. So the unit of Young's modulus or modulus of elasticity is same as the unit of stress, like Newton per mm square, Newton per meter square, kilopascal, megapascal, gigapascal. So in this slide we can see the value of Young's modulus for different materials like cast iron, aluminium, steel and iron. Just check this out. So next topic is Poisson's ratio. So as I told you, whenever a body is subjected to any kind of load, so the strain is developing in the direction of force, it is known as longitudinal strain, and the force is developing perpendicular to the direction of force, it is known as lateral strain. So the ratio of lateral strain to longitudinal strain is known as Poisson's ratio. It is a dimensionless quantity, it has no unit, and the value of Poisson ratio may be 0.25 to 0.33 or 0.35 for most of the engineering materials. So students, I think that is enough for this video, because video has become already very long, and the topic I have covered in this video, it may be helpful for you. So if you like the video, please subscribe the channel, like the video, must comment and share with your friends, and hit the bell icon, so whenever I upload a new video you will get the notification. So keep studying, keep enjoying. Jai Hind.